Hey, hello, hi, welcome back to the channel. So let us so today we're going to be solving the next problem of this series which we are continuing. The pattern is sliding window pattern, huh? So we will solving the problems of this sliding window pattern, and today we're going to be jumping to the next problem of this pattern, the second problem, which is this smallest subarray with sum greater than or equals to target. And actually this problem has two versions. The first one is simpler one and the second one is a little bit harder. The first one we will discuss in this video, the first pattern of the first version of this problem, which can be solved easily by this two pointer technique or sliding window pattern. So let us just jump to the problem statement without wasting more time. So this is a problem statement. We have been given an array of positive integers nums and a positive integer target. Return the minimal length of a subarray whose sum is greater than or equal to target. Cool है? So दो चीजें हैं. The first one is the nums array. The second is the target. And we are supposed to find the length of the subarray, not only length but the minimal length of the subarray, which where the sum of the elements in that subarray is at least equal to the target. It may exceed the target, but it should be at least equal to the target. And we are supposed to return that length. If there is no such subarray, then we're going to return 0 instead. Okay? So let's understand this with the example we have been given. So this is example 2 3 1 2 4 3 k is equals to 7 and अब इसको देखते हैं. So let's see the first subarray, and that subarray is this. 2 plus 3 plus 1 is 6. 2 plus 3 5 plus 1 6 plus 2 8. Yeah, so I found a subarray which has a sum at least equal to 7, and the length of this subarray is 4. ठीक है. अब अकेला ये तो है नहीं, और भी subarrays हैं. So let's move to the next one. 3 1 2 is 6 plus 4 10. Again 4 length subarray है ना. Then let's move to the next subarray. 1 plus 2 plus 4 7. Yeah, I found a subarray which has a sum equal to k but has a length lesser than the length which we had earlier for a valid subarray. So the length is 3 now. Now let's see if we can do even better. 2 plus 4 6. No, we have to extend it to the next element. So 2 plus 4 6 plus 3 9. ठीक है, but the length is 3. Again no updation. ठीक है. So that means the answer for this problem is, the answer for this test case is 3. So the smallest subarray such that the sum of the elements in that subarray is equal to k is of length 3. ठीक है, is of length 3. 3 नहीं 3 तो नहीं है यार, 3 नहीं है. For now it is 3. ठीक है. Let us move the left pointer ahead. 2 4 3. ठीक है. 2 4 3. ठीक है. 2 4 3 is 9. Now let's move the left pointer again towards right. 4 plus 3. 4 plus 3 is 7. So I found a even better answer. 2. Can I get even better? No. Now if I move the left pointer towards right, I will end up getting this 3 only, which is not exceeding this k. ठीक है. So that's the problem statement, the basic problem statement. Let's see how we're going to solve this problem. 2 3 1 2 4 3. 2 3 1 2 4 3. Acha, one thing should be clear here, that the numbers here are positive integers. This is a very critical point here. It seems that it doesn't make sense, it doesn't matter much, but it do. Because why? I will not be going into the detailed analysis, but I will just say, if we have only positive integers, then the prefix sum monotonically increases, है ना? ठीक है. But if we have negative numbers inside this array, है ना, then this thing do not hold, and we cannot apply the simple two pointer technique. Two pointer technique fails in that case, है ना. So that's why this thing will not work when we have negative integers included in the array. ठीक है. then we'll have to keep track of lot of things, and we'll solve that problem in the next video. For now, just assume that we only have positive integers, non-negative integers, or strictly positive, I think, है ना, positive integers. ठीक है. Chalo. How we can solve this problem? Again, 2 pointer we are assuming. So the first is the brute force approach. Generate all the subarrays of length 1, subarrays of length 2, 3, and then sum each of the subarray. The earlier you find the answer, the target, that would be your answer. Okay? This is the brute force approach, but we will not be solving this using brute force. Since we are learning 2 pointers technique, we will be using 2 pointers to solve this problem. So let's start with the solution. So basically what we're going to do is we're going to start with the start pointer. We also take a end pointer. Initialize with them with the first element. Now move this end pointer up until the last element. Okay? And also keep track of the sum in a variable, let's call it sum. So initially this sum is 0. Now since the start and end are standing at the one element, in the first iteration the sum will become 2. Okay? The sum is going to become 2. Okay? Now at this point I am going to check whether, so once we are adding an element in this sum variable, I am putting a check whether the sum is exceeding k or not. Is it exceeding k? No. No, not exceeding. Okay. Move the end pointer towards right. So the end pointer is here. Now in the next iteration again add this element. So 2 plus 3 becomes 5. Is it exceeding k? No, not exceeding k. Okay. So there are two things. It should exceed k. It is not exceeding k. है ना? Now let's in the next, then again move the end pointer towards right, and in the next iteration add this 1. So 5 plus 1 is going to become 6. Is it exceeding k? No. Move it 2, add 2, 8. Is it exceeding k? Yes, it is. Now since it is exceeding k, I'm going to update my answer. So this is my answer. Initialize it with a very large number greater than the length of this array. So what is the length? 1, 2, 3, 4, 5, 6, 7. Initialize it with 7. Okay. Now, so basically n plus 1. It means you haven't found an answer yet. N plus 1. Now 8 is exceeding the target. Now since 8 is exceeding the target, what you're going to do is you are going to 8 is exceeding the target. So what you're going to do is you are going to update this answer. Answer contains 7, but the current length, what is the current length of this valid subarray? Is it valid subarray? Yes, it is. So मतलब ये है उसकी length. What is this length? 4. How we will calculate it? End, which is 3, start which is 0. So 3 minus 0 plus 1 is 4. So update it with 4. Okay. Then what after that? What after that? Move this start, है ना? So in the next iteration move this start to the next number, which is 3. So we will keep moving this start towards right up until what? We will keep moving this start towards right up until this sum is greater than or equal to target. Now exclude this 2. The sum stays 3 plus 2, 5 plus 1, 6. Now the sum becomes 6. ठीक है. Break out of the loop. Why? Because the sum becomes less than k. Now the current window is this 3, 1, 2. The sum of this window 6 is less than the target. So move the end pointer towards right. Include this one in the window. So now the current window is this. I am pointing out 3, 1, 2, 4. The sum of this window is 6 plus 4, 10. The sum is 10. Is it greater than k? Yes. Again update the answer. What is the length of this window? 4. So no meaning of updating because we already have a 4. So we are not doing any better. Now is this k, is this 10 greater than k? Yes. So now we can move the end, the start pointer. Now the start pointer is move the start pointer towards right. Start pointer is here now. So the current window becomes 1, 2, 4 and the sum of this window is 7. 1 plus 2 plus 4 is 7. Cool. And what is the length of this? Is it a valid sum? Yes, it is. It is a valid sum. So since it is a valid sum, we can update the answer. 3. 3 is better than 4. 1, 2, 4. Smaller window. Again, now let us move the start 1 unit ahead because we want to get better and better answer. So since we are getting a valid sum, we will again move the beginning pointer or the starting pointer towards right. So the starting pointer is here 2, 4. 4 plus 2 is 6. 6 is a valid one? No. So now move the end is here. 6 plus 3, 9. 9 is a valid? Yes. What is the length of the now current window? 3. Can we update it? No. Move the starting ahead. Okay. So move the start pointer here. Now it is at 4. Exclude this element. So we had 9. 9 minus 2 is 7. Is it valid? Yes. 7 is valid. So update the length. So what is the length of this valid window? 2. Is it better? Yes. Update it to 2. Okay. Now that's all. Can we move? Can we do even better? We may find a length of 1. Let's try. So again move the pointer, the start pointer towards right. Exclude this 4. So since when we exclude the 4, this 7 becomes 3. Is it a valid? No. Can we update it? No. So the final answer we get is 2. Simple 2-pointer approach. So what we're doing is, so we have 2 pointers, starting pointer, ending pointer. We are moving the ending pointer until the sum exceeds k. Once it exceeds k, we record the length and then keep moving the start pointer until the sum of this window is valid. Once the sum is invalid, we again move the end pointer until it becomes valid, the sum becomes valid. Once it becomes valid, we again record the length, update the length, and now again keep moving the beginning pointer ahead, and until the sum is valid, and keep updating the length. That's the strategy. So why it is working? Because the prefix sum of this array is increasing monotonically. Okay? Why? Now it is on you to think about these deeper level questions. Will not be covering these questions because this thing is purely interview perspective. Will not be moving into the mathematical aspects. Maybe in some other video, in other video we will delve into the mathematical concepts, the prime numbers, those heavy mathematics. We will move, but not for now. Okay. Chalo. Now for this one, what we can do is we can write a code for it. So लिखते हैं इसका code लिखते हैं. So we have answer, initialize it to n plus 1. We have start, we have end, and then while, not end, while end is less than n, sum nums of I, not nums of I, nums of end. Then what? While end, while or this and this sum what we can do is answer is nothing but minimum of answer and minus begin plus 1 and move the beginning pointer by 1 unit ahead, and here update the end pointer. That's all. Finally you're going to return the answer. Simple. What's the complexity? Again, sliding window, big O of n, space constant, not using any extra space. Let's jump to the code and answer 0, and then we have n, which is length of this. No, answer is not 0. Answer should be initialized with n plus 1 while n is less than n, and here sums of right, and here you will have sum initialized to 0. Then we will have इसके बाद क्या होगा, what we can have after this, while, ठीक है ये हो गया, and then we're going to be moving towards this while left is less than equal to right, and right is less than what, not right, sum is greater than equals to k. What we're going to do is we're going to move and by 1 towards right, and then, but before that we have to update the answer min of answer comma ठीक है. And yeah, subtract this nums, the element which we are excluding. ठीक है, we are moving the left pointer and we're going to exclude that element. एंड तो है ही नहीं इसमें, राइट है. Where I'm using num, it's nums, no? Target, not nums. Okay, हाँ. Answer is by default n plus 1. So if there is no valid answer, we're going to return 0. So if answer, like return 0, if answer is equals to n plus 1, else you return this answer. This is the right one. If answer is equals to n plus 1, else return answer. Yeah. ठीक है. So that was the solution, simple 2-pointer approach, and try out. You will find some similar questions here, no? Try out these problems, and you will really try to apply this technique to these problems. You will learn something out of it. We'll discuss this version, not this one, this is a harder version of this problem where the elements are negative in the, maybe in the next video. Till then, keep solving problems and take care. Bye bye.